Hi, my name's Bob Greenyer and I'm a volunteer with the Martin Fleischmann Memorial Project. So thank you for joining me on this evening. I think it's the 24th of July 2022. And I've got a bit of good news for you. Well, hopefully, and we shall see in the fullness of time. But how is everyone? Hi, Definity, Artifact, Cosmic Dave, Richard Mueller, and Corky Goss. It's great to have you in the house. This is going to be a short one tonight. It's just something that came up. There was something else I wanted to do, but I have to finish my poster for next week. I might do a Zoom call after this. If I do, I'll let you know, and I will put it into the blog for fixing Fukushima, second bite of the apple. So here is our title slide for the day. Fixing Fukushima, second bite of the apple. And you can see some 5-litre vessels, I believe it is, over on the right there. And we're going to talk about those and how they came into being. And the data that we see at the bottom there and what this all relates to. But before we do that, I have, for those of you who haven't been able to notice this, an important announcement to make. And that is that this week I managed to get the 1-for-1 version of Dr. Takaaki Matsumoto's book available for print on demand on Amazon. And I will be referring to this book in my poster next week. And so I thought it was important to get it out there for people that might want to have the material in their hands for review moving forward. And I've been reliably informed that it is available in the US, UK, Germany and Japan so far. People have been able to see it in their Amazon stores, and even some of you have actually purchased this, I believe. Peter in Japan has taken the liberty to buy an extra few copies to accidentally leave in some universities or some other institutions, which I think is rather fun idea. Hi Harry, hi Tucker, hi D2105K. Okay, so back to the subject of the day. That is, well, firstly, there's the cover for those of you that missed it. And I have this breaking and making matter here. Because that's what it would appear to do. The itonic clusters or microball lightning. And this was the only color image in all of the source, so I put it on the back cover as well and tried to keep it relevant. And this is my favorite image, I think, in the whole book, not only because we replicated it using a Mars gas on indium, but because it replicates the work and claims of one Mikhail Solin in his patent in 1992, where he says that the magnetic solitons of two charge types cluster together and they form spheres and tubules, and the nuclear reaction goes on within those, producing standard elements, predominantly things like alpha, carbon, silicon, calcium, iron and such like. And this is a lead ball that was produced out of a lead wire, no surprises there, in a 1996, I believe, experiment of Takaaki Matsumoto. And it had potassium hydroxide and also light water in the experiment. And the plume coming out of here is apparently, according to Takaaki Matsumoto, largely carbon. So this was carbon coming from inside a sphere that was produced in a system without carbon. And so this matches what was said by Solin in 1992. It is the observation we had coming out of indium and more recently coming out of a crenellated sphere on the eastern plateau of the Vega Valley by Henk Uren in Holland. So I think this is pretty conclusive that this is how it works. And what is really relevant today is that that crenellated sphere that produced that carbon spewing out of it on the eastern plateau of the Vega Valley is also exactly the same type of structure as we observe in water and cavitation in ultra experiments, and that will be very relevant for what we are going to talk about today, and that is fixing Fukushima. Second bite of the apple. So I only have 2 slides here, and then we are going to talk about why we are here. Hi, Watkins. So the timeline here is that on the last days in December the 30th, 2021, the MFMP sent their proposal to 9 sites. And on January the 11th, 2022, one Japanese gentleman, Yuji Miyake, having got information from my colleague in Japan and I think from Dr. Roishin Amaza, requested that I send him the MFMP's proposal. And so on January the 14th, which was the earliest opportunity I could do it, I sent the full proposal to one Yuji Miyake. In mid-March, 9 sites, which, if for those of you that don't know, they are the sort of evaluating body for proposals for cleaning up the what is now 1.25 million tons of tritiated Alps water. They rejected our proposal, and they said they wanted us to reapply with quantitative and qualitative data. Now, we were in a bit of a bind because obviously we can't get tritiated water from Fukushima, and we said we'd like to do the testing there. Of course, that's the most appropriate place to do it. However, that wasn't going to happen because we can't even travel there because of the restrictions. However, I found a workaround following a tip-off from a member of the crowd, how we could use a specific device that was used for detecting radiation in water. The whole point of it is to do that, and it comes with you can get a control sample, which is tritiated water that is in 10 millimeter volumes that was actually the control sample for the device. So we thought we could do something with that, and on the 17th of March I proposed that in the video link you see there. However, with some effort, we found out that we needed to have a place where we could receive radioactive material, and we needed one of these devices. We did have a sponsor to cover the £10,000 it was going to cost to buy the tritiated water for the experiment. However, we didn't have access to a place that could receive this, or basically no one that had one of these pieces of equipment or could receive the tritiated water was willing to assist us in our process. So we hit a bit of a dead end there, and we made that public. At the end of the sort of March-May period, that was what we were doing there. Anyway, having showed the work for the cover for Dr. Matsumoto's book reprint, Sho contacted me and said that Yuji Miyake had made another proposal, and that was sent to 9 sites on the 30th of June. So what we are going to do here is to review Yuji Miyake's proposal, and we can see where they are at. And I think it's rather exciting because what would appear to have happened is that obviously well before we got the rejection or in March, he had the document to work with from January the 14th, and he could see the reported problems that they wanted addressed. He could see that we had difficulty in... We had a solution, but we couldn't execute on that solution because the rules are in place to make that essentially impossible, it would seem. And so they moved ahead with a proposal, which I think you'll see is trying to get round that, and also do what my vision was a Japanese solution to a Japanese problem. And this is good to see. Anyway, so Show sent me the link to the proposal, and I said, well, okay, I'll have a look at that when I can find the time, the day before yesterday. And I said, but you know, if they need any assistance or help, I'll be very happy to give it. And I'm sure that would be true of all the other people involved with this work, being Slobodan Stankovic, Alan Goldwater, Henk Uren, John Hutchison, Dr. Alexander Parkhomov, and David Buttilia. I'm sure everyone would be very happy to assist with their work. Anyway, so let's have a look at this. Okay, so let me pull up their presentation. Now, I'm not going to go into the Japanese, and I have to ask you to accept that I've done a rough translation. It is from the Japanese. I'll do some real-time corrections where I think I know that the translation is wrong. The presentation slides were provided as PPT, and there was some speaker notes. So I will read the speaker notes that are attached in the presentation, which I also translated with machine translation and using my own understanding of the subject. Again, there will possibly be errors there, so if Yuji Miyake can forgive me for that, that would be very generous of him. So I'm going to play this now. Okay. And for those that are listening in Russian, I have Russian translations of my spoken word at the bottom of the slide. So it's actually not gone from the beginning, so we will go from the beginning here. So this is extinction of tritium by cold fusion, phase 1 principal confirmation. And this is provided to TEPCO via 9 Sigma. This is the proposal. I think maybe you can go onto 9 Sigma site and maybe gain access to this proposal. And you can see it was submitted on the 30th of June 2022 by SDG's Association of Engineers, and the principal proposer was Yuji Miyake. So the speaker notes here are: the proposal is not an extraction or separation technology, which is actually what 9 Sigma were asking people to bid for, but an extinction technology. I like the word extinction. I would possibly, that might be a translation error. I would, in English parlance, I'd probably say remediation technology, but maybe extinction is a more accurate term. We are completely getting rid of the radiation, that's the point. Physical and chemical separation methods do exist, but they are not cost effective and cannot be put into practical use. And that's proven by the fact that they're not accepting any of those proposals that are in those areas, the sort of separation and concentration. Even if the cost problem is solved, the separated or extracted radioactivity will persist and must be safely stored. So the idea was that they would ask people to reduce the radioactivity to 1/10 of 100%, sorry, 10% of the original value, and then that, I guess, would be dumped into the sea. So there's always some radiation going into the sea, and there's always some concentrated material to have to store. The reality is that nuclear modification requires ultra-high temperatures and pressures, and even if it were possible, it would not be cost competitive. We believe that the only way to make it cost-effective is by what they are referring to as room temperature transmutation. So why via 9 Sigma? TEPCO, in accordance with the government's decision, show the world that you are ready to concentrate on releasing. So that's obviously a terrible translation. Harnessing 9 Sigma's ability to gather the world's wisdom. I think that's a good point there. And a subcommittee on treated water for multi-nuclide removal facilities, etc. Social presence that can compete with. Okay, so it's just not good translation there, but the speaker notes might help a little more. Practical application requires the collective wisdom of the world, and we look forward to the global network of 9 Sigma companies. The Society of Professional Engineers and the proposer do not have the strength to implement practical applications, and we hope to conduct joint research with TEPCO and others. JFE engineers are also participating in Phase 1, and JFE has the potential to bring together technologies from around the world and is the shortest distance to take over to Phase 2 practical implementation. A government subcommittee has concluded that no practical level technology exists and a large social presence is needed to switch government level decisions. So what they're saying is, right now there's no technological solution that will affordably concentrate and or separate the waste. And so they made this decision to dump the water into the sea. But really, it needs a very intense social awareness that there potentially is a solution, and that this may be the right way to go, is kind of how I'm reading that. In order to help the government make a different decision. TEPCO's participation as a joint research partner is the minimum required to achieve social presence. And I would agree with that. That's what I was arguing with back at the end of last year, and really it needs their participation. And I don't understand, for me, why, when I believe that we could have socially funded the exploratory tests in Fukushima, that they wouldn't want to explore that. I have given a couple of reasons. Maybe that they don't want people having access to the tritiated water because maybe it's not as clean as one might hope, or what they are suggesting it is, but maybe that's not the case, and maybe there's just too many procedural barriers to overcome to make that a simple process. Anyway, we hope that the MFMP will be involved in Phase 2 and that it will become a gateway for the expansion of fusion technology to the rest of the world. Absolutely wonderful to hear. That's a deep honour that you would suggest that we would be willing to be involved, and I'm sure that many people that have supported us over the years and worked with us would want to do everything in their power to ensure that if they had some skill set and intellect and understanding that would be able to mitigate this problem or solve it, that they would come on board with the Phase 2, which you will see at the end what that's proposed to be. So it was nice to have immediately said, I think I can speak for myself, and I'm full up for helping them in any way that I can, and I'm sure that would be the case for everyone else. And then I see in this proposal, which I read this afternoon, that they would very much like the MFMP to participate in their work. So that's very good to hear. Hi, Slobodan. So essentially what I'm reading about here is a sort of second approach at 9 Sigma to deal with the radiation at Fukushima in the tritiated Alps water, the 1.25 million tons. Just to give you a short overview, and that they took the learning from where they criticized our proposal. They understood that there was no moving forward unless there was some sort of quantitative and qualitative data to make a decision on. And so they've done a bit of that, and they resubmitted a proposal, and they've requested that they would very much like the people in the MFMP that have the skills in the relevant areas to be part of the second phase of the investigation, and that, as we said, they have reiterated it really requires the cooperation of TEPCO, and so that probably catches you up to date. Hi Maria, hi Gordon. Right, so why cold fusion? Physical and chemical separation technology is cost impossible. Conclusions of the subcommittee. So that's where they are already. Calorific generation by cold fusion has been confirmed, and industry is starting to move forward, I guess. Cold fusion theory proposed 30 years ago. We're talking about Dr. Takaaki Matsumoto's confirmation of the existence of low-cost fusion technology. Okay, so the great thing is that there will be people presenting in the coming 7 days that will show that really in Japan there are a number of parties that have proven that whatever cold fusion, as it was called, whatever it actually is that's going on, is a real thing, and that there is what appears to be some output nuclei that are different from the input nuclei, and that some form of saying heat here, I guess, is able to be produced. So there is a process, and it is real. And so the speaker notes here is nuclear transmutation at room temperature was announced about 25 years ago, but as a result of the follow-up test, it was decided that it was a mistake. However, efforts are continuing, and we are now in an era where private companies are being established on the promise of cold fusion. Based on the bitter experience of the past, this technology development needs to proceed cautiously. In order to get the academic community to approve it, it is necessary to propose multiple new technologies and have the academic societies recognize that nuclear transmutation is occurring on the same principle, or by this principle. It is only when the society recognizes the principle that it is necessary to advance to the level of practical application, and this proposal is confirmation of the Phase 1 principle. Phase 2 describes only the outlook and does not include it in the scope of the proposal. Okay. So the advantages of cold fusion is there's no need to take out the debris, the radioactive annihilation of, because the radioactive material can be annihilated on site. So this was essentially a key part of my proposal, is that, you know, we could actually use this process to remediate the material on site. Utilization of radioactive materials, so they could actually be put to use rather than dumped or stored indefinitely. Power generation by microball lightning generation. Okay, and so you're starting to see the work of Takaaki Matsumoto coming in here. Conversion of high concentration radioactive materials into raw materials for power generation. Okay. Production of precious and rare metals, and that might not be the case with tritium, but we did see silver being produced when we did HHO onto calcium carbonate. But if you're starting with heavier metals, of which there will be a lot of heavy metals given them in a typical nuclear waste sample, there's the opportunity there potentially to produce stable elements that contain, or stable material that contains a wide range of precious and rare metals. Forest decontamination possible. This is, I think, a pretty intractable problem. It's not just the water that they have there. They actually have these almost mountains of topsoil that are in bags sitting around the Fukushima Daiichi region, which have to be dealt with also at some point. Now, there are the proposals by my friends in the Ukraine, who with my tiredness slipped my mind, Vysotsky and his Russian colleague Kornilova. I have a relationship with them, and I'm sure they would be happy to come on board to deal with the forest decontamination there. I think they've already been working with TEPCO to some degree, but there are other approaches here as well that can be used with the technology that we're looking at in this proposal. The status quo is virtually impossible. So basically, some of these things cannot be fixed. You know, there just isn't an option to fix these things, and it's weird that we're in this world where there's all this radioactive material, and it's kind of like, let's hope we can do something between now and 2050, and it's like we really need to move forward if this is ever going to be delivered, we don't want to find out in 100 years' time that we could have solved the problem, 80 years previously. So, we kind of have to take the options that we have on the table and move forward, I believe. Redecontamination is required after 100 years. So, as you move forward, you're going to still have contamination from the stuff that you store, let's say, and you're going to have to, because it's emitting radiation or whatever, it's going to cause contamination. So you can have to scoop up a load of stuff that's been recontaminated and decontaminate it. So the idea here is you're going to try to get rid of it completely. So the speaker notes here are: in addition to the disappearance of tritium, there are the following merits. TEPCO is struggling to remove debris. The reason for this is that it is difficult to shield a lethal radioactive environment. If functional water generated by this device is used as cooling water, there is the possibility that nuclear conversion will be performed and it will change into stable substance, and there is no need to take out debris. Okay, so what I've argued in the past is that the cavitation produces strange radiation quanta that are effectively in the water or in the water gas, and that these going into the cooling pools or the cooling water that is washing through this melted down reactor, these fractal solitons, as we might like to think of them, could travel into the radioactive material and reduce its activity over a period of time. So they're already putting water in there to keep the reactor cool. This produces the highly radioactive water that contains a range of elements and also tritium. This then goes through the ALPS system, and that removes the other elements, and you just end up with this tritiated water. And so rather than going through that process, what you actually do is you have these systems where the cooling water is cycled through the vibration system, and it's effectively sending these quanta. Now, we know from cavitation in the rotary system of Shishkin that it is producing these string vortex solitons, which may be these coherent matter traveling waves, or you might like to think of them as these clusters of interlocked fractal solitons of vacuum current loops, and that they, let's say, are traveling, and as they travel, the silver excites them on the film, and they leave their birdies in the film, those kind of like birds or like split mushrooms that we've seen in various experiments. And so if they are in the water, do they travel with the water, if that's a possibility? Or if you have a cavitator, like it's put into the cooling water itself, it could emit these things and lower over a period of time in situ. So these are all ways that potentially these technologies can be used, and you just actually need to do some trials and work out what is doing what. Okay. So with the stabilization of radioactive materials, micro ball lightning is generated and current is generated. Power generation is performed by extracting electrical current. In addition, depending on the raw materials, there are also those that are converted into rare metals and precious metals. So essentially they're saying that by taking the radioactive materials and using ball lightning, there are methods, and some of those we've discussed, and we're going to be discussing more methods that have come out of the patents which are about to expire. But anyway, there are ways of getting electricity out of these things proposed, and therefore you actually, if you've got electricity to power this thing and you're getting electricity out, and it's maybe at a nuclear level separation between the two, then we might be able to, at least on a power basis, run the decontamination from the decontamination process itself. Decontamination to remove the topsoil of the forest is dangerous because it leads to the collapse of the mountain massif. But it is possible to decontaminate the forest by spraying functional water by helicopter. So this is water that this company produces. Now, I don't know whether this is electrolyzed or vibrated. Either way, I think it would produce the same sort of thing. I think what they're saying is that they're getting some quanta of atomic hydrogen into the water, and that actually does some remediation itself. I do know that when I was in Sochi, they were doing corona discharge onto water, and that this had all this ability to promote seed germination and growth, and also prevent disease. And this is also the claims for the cavitated water from the Shishkin rotary device. And of course, I've talked about the vibration system producing water. Now, the idea is by Dr. Roshin Amaza, when he's doing that and for cultivating fish, it's really purifying the water. But I've argued that it's producing, one, the monoatoms of freshly synthesized elements, but also it's producing this special water which may contain, as these people are claiming, hydrogenated water, where it has the atomic hydrogen dissolved in the water, and that has an extreme bioactivity. And so that may result in these very large eels, these very large fish that I witnessed in here, Nippon Techno, Japan Techno, his organization in Tokyo. Okay. Residential areas and fields are decontaminated by stripping off the topsoil, but in 100 years, radiation will move from the forest and there is a need for re-decontamination, but that fear can be avoided. Okay. So, yeah, this last point here, this re-decontamination is required after 100 years. They're saying, like, we can fix the fields where people are living, but in 100 years that there'll be rain and it'll wash down and you'll be contaminated again. You'll have to do it all over again. So what they're suggesting is you have this functionalized water, this hydrogenated water, this may be this string vortex soliton containing water or whatever it is, and that you then spray this over the forest and it decontaminates the soil in situ. Okay, so there's not a problem with this decontamination. Okay, so next. The necessity of joint research with TEPCO. The proposer has no radiation control zone. The establishment of controlled areas is financially burdensome. So this is the problem that we faced and we couldn't find a solution to between March and May of this year. And that is that you have to have an official sanctioned radiation control zone to work with radioactive materials. So it's very difficult for you to take these technologies forward. Now, the incredible thing that they're saying here, facilities in all areas of Fukushima are on par with those of a management area. So they're saying that the entire area of this Fukushima exclusion area effectively qualifies as a radiation control zone. So not only do they have all of the material that they want you to clean up of all of the various types, they also don't need any permission for that work to be undertaken. And that was essentially, without going into this much detail, my point that I was trying to make in my proposal is that, like, we need to work with you. That's the best place to do it. And so they are making that point there. Obtaining a wealth of samples. It retains large amounts of tritium water in the Alps system, treated water. Pre-treated filters and sludge from contaminated water sedimentation ponds are also readily available. TEPCO's participation is necessary to attract the wisdom of the world. Fully buy into that. Now, you see, the difference between what Miyake is doing here and what I could possibly achieve is a Japanese person understands Japanese culture, and he understands how you approach a Japanese organization to open those doors. something that I'm not culturally inept at, culturally incapable of doing. And so these phrases here is yeah, we can do this, but we need TEPCO involved, and I think his argument's very good here. So he's saying in the notes here, handling tritium involves setting up a radiation controlled area which is regulated to ensure that radioactivity is not taken into the environment. The participants are not in the business of handling radioactivity, so they have to set up a controlled area for the experiments, but they do not have the wherewithal to do so. TEPCO considers that the whole of Fukushima Daiichi, the exclusion area, is isolated from the environment, equivalent to a controlled area, and that the controlled area is maintained so the experiments can easily be carried out. The equipment for the experiment can be set up in a space of 10 square meters, which is also easy to install. If TEPCO is the co-experimenter, participation from abroad can be expected. I 100% agree with that. Bang on. Wonderfully said. So thank you, Yaki. Okay, so the test equipment here, you will have seen something similar to this during Project OMO that we took videos of and assessed for various parameters in 2019 in Japan. And very simply, it's a vibrating motor or a vibrating wing is suspended, and that's a 5-litre beaker. So this is a test equipment. The diagram shows, or the picture shows, the experimental apparatus at Nippon Techno, which is Japan Techno. Tritium water in a 5-litre beaker is detoxified by vibrating a multi-stage wing similar to the tail of a dolphin, suspended from a vibration motor. The device is very simple, can be remotely controlled and operated unmanned, and can easily detoxify highly contaminated water. The treatment of used filters of contaminated water generates high concentrations of contaminated water, which can be safely treated remotely. Okay, so I guess that they are talking about the filters that are designed to remove the other things like cesium-137 and strontium-90 from the water, the cooling water that is used to control the decay in the melted down reactors. And so what they're saying is these filters, they need to be washed out, like maybe like reverse washed, and that produces really highly contaminated water, and then that can also be processed in here. So it's a system that can not only apply to the tritiated water, but also to the other contaminants that are extracted from the cooling water. So the transmutation proposal here is that you start with your tritium, and so I guess this is the proton and these are the two neutrons, and you have an electron here. And through something, this magic arrow, you end up with helium here. So to do that, we need to get a monoatomic hydrogen and get the electron and the proton to fuse somehow with a what do we call it? We need a antineutrino, and those to fuse to a neutron, and then we end up with a helium atom. Okay, so that is the kind of like schematic there, and the notes on this is the predicted formula for the transmutation of tritiated water. There is a history of previous attempts at transmutation to helium-3, but with a mass of 4 helium. This needs to be confirmed by elemental analysis of the gas after the test. So yeah, so if you add tritium and you ended up by making TH rather than H2, right? So that's one tritium super heavy hydrogen and one H, that would have the same very, very similar, all bar a neutrino, antineutrino mass or whatever, mass as helium. So you need to have very accurate gas analysis to detect that. Obviously the tritium, the TH would be explosive, whereas the helium wouldn't be explosive. Okay, so it does need that test afterwards. So the process that they're giving here of the nuclear transmutation is the vibration agitator generates nanobubbles without the use of alternating current electrolysis. The nanobubbles self-shrink due to surface tension. So self-contraction occurs due to the bonding forces between molecules. Electrons are absorbed around the nanobubbles. The distance between adsorbed electrons is further reduced by intermolecular bonding forces. The bonding force between the electrons is strengthened by the Bose-Einstein effect. The tritium water vapor, which is compressed by the electron bonding force, is decomposed into tritium and oxygen. Tritium is converted to helium. Okay, so there's a number of things in here. It is a potential explanation here. I'm going to read the notes before I make some comments on this. So Natto Theory postulates that bubbles are generated by alternating current electrolysis, and that macroscopic high temperature, high pressure state is generated by self-contraction due to the binding forces of electrons. So what they're talking about is what I showed you at the beginning of this, which is on the cover of Steps to the Discovery of Electronuclear Collapse, which is you are getting electrolysis, and I have said, and it was never said as far as I can remember, that effectively he is creating HHO. He is creating separated atomic and molecular hydrogen and oxygen in a mixed gas. That is what's going on when you do this AC electrolysis. That is what I've said. That is where I believe a lot of these systems, even Pons and Fleischmann, was effectively creating oxygen and hydrogen in his cell, or in their cell. And so although they were using DC, but it's slightly different setup. But anyway, in Matsumoto's it's more equivalent because he was using AC in that test, which I have that picture on his book. And that this is creating HHO, but then you get bubbles forming, and then because of the gas production, and then they collapse. And I've said that where you get the bubbles forming, you will also potentially get some easy water. You've got the polar water molecule. All of these things are playing a role along with the charge separation. Now, where they're saying Bose-Einstein effect here, I will hear some physicists bending their necks and courting and doing genuflex or whatever, because they will say that's not possible with electrons because they are fermions. But what we've learned from the making coherent matter wave patent of Lockheed Martin is that you can get fermions if you get them at exactly the same temperature, and you get them at exactly the same phase, or you give them an opportunity to get into phase by putting them through microcavities, then you can get electrons to cohere. And Ken Shoulders would suggest that this forms an electron condensate, and you can imagine therefore that the distance between those electrons, if they're forming a condensate, goes from very large to much, much smaller. So this is the collapse. Now, are they forming bosons, which is suggested, I think, in 2012 by the ultrasonic cavitation expert Roger Stringham? He is proposing that the deuterons under ultrasonic cavitation, and we found that the vibrator plates of Roish and Amasa do produce ultrasound, that produces a condensate of electrons around the deuterons, and then that does self-compression. So essentially what they're describing is the same effect. What we can say is from our ultra experimentation, we have produced, in the work of 900 seconds by my wonderful colleague Alan Goldwater, these hollow crenellated iron spheres. And these are exactly the same structure we see produced in Vega experiment, that we see produced in the Nova experiment, that we see produced in natural ball lightning from Hessdalen. So something is being produced which is equivalent to ball lightning. Now, ball lightning can have a black mode. It can have a luminous mode, depending on what's going on. And there are many papers that we've referred to and many that we haven't referred to that discuss this. So what is going to be happening is you are getting coherent matter, and that is the suggestion that is going on here. It's a coherent matter cluster, and I believe that this produces superfluid, superconducting magnetic flux loops that self-organize, form these meshes that is referred to as the Natto ball, the dough ball, the fermentation of the nuclei inside, and the self-collapse process that is referred to by Matsumoto. Anyway, so while this might cause some nuclear scientists to have a real problem, I believe in spirit it is correct. So the tritium water vapor, which is compressed by the electron bonding force, is decomposed into tritium and oxygen. So this is not by electrical, but charge separation and, you know, the ripping apart of molecules and so forth, which I believe is very capable of doing in these high pressure change systems. Tritium is converted into helium. So when you are trying to get things to cohere, you want to get them into a incredibly low state, incredibly limited degrees of freedom. And I think the smallest degree of freedom you can possibly have is when you have a nanobubble that collapses onto a point. Okay, so you might have charges all the way around. You've got your easy water on the outside, you've got your polar water molecules, you've got the free electrons and the free protons and the free or the ionized oxygen or whatever, as it's split up, as it's produced this plasma or just this gas bubble is produced. And then as it collapses in on itself, the degrees of freedom of all those free electrons on the surface or the easy water or whatever, as it's coming into a point, the degrees of freedom are reducing and reducing and reducing to such a point that it's literally it's at one point. So they kind of all have to be almost exactly the same energy. And the phase, you know, if they're out of phase, when they get rammed together at that point, maybe this provides the conditions. You have to think about the process that is doing it, but regardless, we get these spheres, which are these crenellated ion spheres. So sound can do this. It does it. So, you know, and it looks like ball lightning is a coherent matter effect. And so you're trying to create coherence. They're talking about Bose-Einstein condensating here. Whatever. I think they're on the right track. So, so the notes are here in after the AC electrolysis. It says, so I'll read the speaker notes here in entirety. Natto theory postulates that bubbles are generated by AC electrolysis and that microscopic high temperature, high pressure state is generated by self-contraction due to the binding force of electrons. I agree with all of that. In the present proposal, nanobubbles are generated by vibrationary stirrer, which may be self-contracting due to surface tension, facilitating the coupling of electrons. I agree. And when they're saying coupling of electrons, that is two electrons becoming coupled into a Cooper pair. That becomes a boson. Therefore, they can form Cooper pair Bose condensates. It is assumed that the bonding force between electrons further contracts due to the Bose-Einstein effect, resulting in high temperature and high pressure conditions and transmutation. And that is essentially what is said in the 2012 work of Roger Stringham, probably the world's expert in cavitation. He will also be presenting, or a colleague will be presenting on his behalf, I believe, at ICCF 24. We believe that tritium is converted to helium and would like to confirm this by elemental analysis of the material after treatment. Okay. So next slide is a schematic. It's quite a nice little schematic. So I thought this was titanium oxide to begin with, and then I realized there's no I, and then I thought I'm an idiot. This is T2O, so this is tritium oxide. Okay. Now the reality is that in the water there will be T2O, there will be TDO, and there will be DDO, and there will be HDO, and there will be THO. So there'll be a whole mixture of things, but whatever. So this is our bubble. Okay, and I guess these are molecules of water around here. And there's the binding between the molecules here. And with the vibration, the bubble expands and goes to closed and collapses down via this surface tension. And this whole area here is the tritium water, the whole area here. Okay, I guess this is a tritium water gas. Okay, and possibly becomes a plasma in here when it gets down to here. And so they're saying that these collapse together, and so you end up with the Bose-Einstein condensation as the coherence increases in the collapsing bubble as the electron bonds come closer together and they form a coherent matter condensate, and that crushes the components in here and it goes to helium. Now, when you're looking at this, oxygen is effectively 4 helium nuclei. Okay, it's quad alpha. T2 isn't. However, it's 2 protons, sorry, 2 protons and 4 neutrons, right? So, you basically have an excess of, I guess, neutrons, or is that right? If you want, you want 2 protons and 2 neutrons. You can have 2 neutrons left over, but like I say, the actual water will be a mix of these different isotopes, where actually this T2O is quite rare statistically. So, and they're not saying it immediately reduces it. It takes time, and so it's an iterative process. And when things are at helium, they wouldn't do this process because helium, the nuclei, the alpha nuclei, is already the most efficient packing of nuclei that there is. You might end up getting heavier elements like, I don't know, carbon, or you might end up getting heavier elements like calcium or things that we observe. But it's not going to remake tritium in this kind of way. Okay, that's the kind of suggestion there. Okay, so this is the transmutation status. At the start, at transmutation, sorry, was there any speaker notes on here? No, there wasn't. Okay. And this is what it looks like at the end. And so their question is, at the end of this period, the radiation, as you'll see on the next slide, reduces from 0.5 microsieverts an hour, I guess, yeah, down to 0.11 microsieverts an hour. And it has all these bubbles in there. So what they are suggesting is this is potentially helium gas. And if that's the case, then we need to do some assessment on this to find out whether it is actually helium gas. And so that's what they need. And in fact, we have the tool to do that in California. Alan Goldwater has the tool. The project has that tool available to it. And so we could seal this off, or make this a more sealed type of chamber, and we could use the process mass gas analyzer that we have and detect whether this is actually helium or not. So we have the means to do this, we just need the location to be able to verify it. So here is the measured data. Sorry, I'll see if there's any notes on that. Okay, so on this slide, the notes are: the figure on the left is the transparent water before the start of the experiment. After stirring for 20 hours, this is the end point after 20 hours, it appears that the cloudy gas has been generated as shown in the figure on the right. They predict that it is helium gas, but we will need to confirm it by performing elemental analysis. So this is the chart of the decay, and it's actually, fairly steady chart going down. There's a very steady trend line. I would expect this trend line to tend to go flatter as it goes down, just because of the statistics of that. So I would have liked to have seen this experiment conducted for more than 20 hours, because this looks more linear. But one could argue that it's going to an asymptote down here. But anyway, that is as it is. So it starts off here as in microsieverts per hour, 0.5 microsieverts per hour, and as it goes down over 20 hours, we go down to 0.11 1. So that is in a 20-hour period. We have a reduction of, what's that? It's kind of like approximately 80%, isn't it? Now, they demand 90% removal of tritium from the water. So this is not far off that. And it might be, we might be very lucky that the asymptote goes down to 0.05 of a microsievert, and then you would have hit the target. And where that comes, I don't know. But like I say, I would have liked to have seen, a longer run. But I think if this is verified, this is fantastic data. It just is fantastic. 0.25 here from 0.5 has a timing of around about 4.25. So they're saying that the half-life is around about 4.25. So the notes here are, the figure is a graph of the transition of radioactivity with 20 hours of continuous stirring. The initial dose of 0.5 microsieverts an hour halved to 0.25 microsieverts an hour after about 4.25 hours. Normally, the half-life is said to be about 12 years. It's actually 12.3 years, but it has been shortened to 4.25 hours. I think that a large amount of beta rays are generated, but I think that it does not go out of the beaker because it is a low energy amount of radiation. The actual beta ray is not that high an energy. In future experiments, we will be able to measure it. So they've got measuring the experiment beta ray measurement with liquid scintillator, micro ball lightning imaging, nuclear sensitive plate photography, microscopic photography, and elemental analysis of generated substances. So these are, I guess, methods that you could propose to do it. Now, they're saying in the notes here, the beta rays generated from tritium have low energy and are not emitted outside the beaker. So the sample is sampled regularly and analyzed with a liquid scintillator. So this is the technology that I was proposing to use to prove that this process could occur. So maybe they actually did it. I would like to know if they used the device that I was suggesting that was linked to me. Anyway, they were looking at a device that looks at liquids and looks for scintillation coming from that liquid. It is thought that nuclear transmutation occurs on microball lightning, and traces are photographed on vibrating blade by microscopic imaging and recorded on nuclear sensory plate. So these are technologies that we have used, that the Russians have used, and that Takaaki Matsumoto is an expert in. Please refer to the photo on the next page. Okay, so I'm like I say, I'm not sure or certain, but they had to come up with this chart. So I think that this must have been done with that liquid scintillation technology in line with what we proposed back in March. And so that's great. One issue I have with that is that we understand from Shishkin's work that the strange radiation can come out and bind to the photo scintillation sites in a scintillator and give spurious readings. That being said, I don't think necessarily we would have had this kind of continuous trend going down. I think probably that it would have been spurious reading, so sometimes it would be up, sometimes it was down. To get around this, knowing that these structures last for about 2 days, I would suggest that if we got an opportunity to take experiments forward with this, or without us, that they would conduct experiments where they vibrated for a number of hours, and then they waited for 2 days, and then they did their scintillation test. Then they vibrated for another couple of hours, then they waited for 2 days, and then they did their scintillation test, and then they vibrated. You get the point. And so what I'm suggesting there is we want to get rid of these persistent, potentially exotic vacuum objects, which potentially could be self-similar fractal toroidal vacuum currents, which do the remediation, but potentially can also interact with scintillation photosites and cause spurious readings. So My desire for an experiment that would be very, very reliable, given what we know about this radiation now, would be to do the proposal I've just made. Of course, if we are making these structures and they are carried physically along with the water, as one might expect they might be, then this means that the water that you are processing, as they argued earlier on, could go into the plant as recycled cooling water, and for 2 days it could be working its way through and doing its magic on remediating the waste in there. I would like to see, on that basis, a lot of control tests with samples of highly radioactive material to test that we didn't trigger something to run away, essentially. So I would like to do some control tests. There is a data point with John Hutchison where his equipment was able to remediate I think it was a uranite sample, okay, this was going to be in his book, but this is probably the most amazing thing that John told me. Nearly the most amazing thing that John told me, but I think it's relevant to talk about it now. As John would say, no secret squirrel stuff. He was asked by this radioactive sample supplier to see if his technology would remediate I think it was a uranite sample or something. Anyway, so he processed the sample and sent it back to them. And a couple of weeks, firstly they said, oh yeah, the activity of the sample's gone down. And then a couple of weeks later, he wrote back or phoned him or whatever. I don't know exactly the communication that went on, but he says, don't send me any more treated samples. And John goes, like why? He says, well, all of my other radioactive samples in my lab, they've lowered their radioactive output. So whatever had gone into that sample was self-feeding and replicating things that were coming out and accelerating the decay of other samples in his storeroom. So I don't know how big the storeroom was. Maybe it's a couple of shelves. I don't know, but one can imagine. And if this is true, it could be a self-feeding process, which is a how should we put this? It's a chain reaction. And when I after ICCF 24, I will be translating the Shishkin papers that I've got his permission to do, and you'll see that this is a possibility, and that this probably was what led to the exploding reactor at Fukushima and played a principal role in the accident at Chernobyl. So I there's a potential for great benefit, because this guy didn't report that his lab blew up. It's just the rest of the samples in his lab had lowered their activity, which makes them useless as radioactive samples that you're going to sell to someone else. So he was not pleased. We know that these things have a defined range. So, if you had this sample that John had treated, then if it was a small volume, then it might contaminate other things and then contaminate other things. And we do know that these things can contaminate via electric conduction, because they can pass through as effectively like electrons, and we know this from Matsumoto's work. He says it's a new form of electricity, and I believe that, and I've argued in the past, that this is what caused the blowing up of the Tesla substation, and also the Chernetsky power station, and also some failures of transformers of John Hutchison. That these things, they go down the wires and they don't like induction and stuff, but what I'm saying is that they can conduct, and this was done by the Soviets in the 1980s, where they created these structures with a Tesla coil and a spark gap, and they were able to transfer 25 kilowatts down an 8 micron wire. So that many people have understood aspects of this, but now we understand that there is this coherent electrons that may or may not exist, and it could just be this vacuum pointing vector cluster, totally exotic vacuum object, not dependent on matter, but can interact with matter if it's excited, and then maybe once it's excited, it then can fall apart or be transported along with matter. It could have been in that urinate sample, went to that went to that stock room, decontaminated or reduced the radiation. So I think there's a real argument to say that there is potential to use this technology to remediate the nuclear waste in situ. And I have given an explanation for how this company's technology, this so-called hydrogenated water, but I think it's actually these clusters of things that are produced in cavitation or electrolysis, can remediate soil in situ, because it will have these exotic vacuum object clusters, and they will be released and they will do their business, and it's just a thing of beauty. So I think that if we are allowed to fix this, I think I really feel we can fix it, and it's only artificial man-made barriers, I believe, that are preventing a solution being delivered here. A real solution that will mean we have no excuse really to not use nuclear energy, which is one of the few sources of energy that are not derived from the sun, or hydrocarbons, which arguably, if you believe that they are all from Dead Sea animals or other things, rather than a biogenic production of gas and oil, if you say they are all biogenic, then they came from the sun as well. So so I think we need the opportunity to do this, and I think these are the right people in the right place to try and get a foot in the door. And I think this tells us a lot on this chart, what is going on. And I believe that I would like a statement from John Hutchison about that example that I just gave. And sorry to John if I put that out there at this time, but I think you are alive to tell those stories. We're working with a lot of near or actual octogenarians in this process, and the opportunity to benefit from their learning and deliver civilization-changing technologies, that window will shut if we don't all pool our resources and experience. Okay, so measuring the experiment we've just gone over, and so they are referring to this diagram, which was thankfully put together by Dr. Felix Scholkman for me. And down the bottom left, you will recognize the image on a metal plate by Dr. Takaaki Matsumoto from 1993 in fusion technology. And this is a colorized version showing the hexagonal itonic mesh lattice. And you can see two examples that we observed on a Amasa vibrator plate. And so essentially what they're saying is that both technologies can produce the same outcome. One was with electrolysis, one was with charge separation, but not using direct electric fields, but fields generated during the process of cavitation. And Ken Shoulders very clearly says that cavitation bubbles will produce charge separation, and that's all you're doing by providing electric current to an electrolyte. So the speaker notes here are: this photograph shows a mark that was present on the surface of a Nippon Techno, that's Japan Techno oscillating wing, in 2019, and is attributed by the finder Bob Greenier as the exotic vacuum object mark. The bottom row of the figure is extremely similar to a photograph submitted by Takaaki Matsumoto to Fusion Technology magazine in 1993. So he's saying the bottom row here is extremely similar. So with this boundary, this fall-off boundary, and the overall structure here. The left photo on the left was taken, and the right one has been enhanced to make the hexagon easier to see. The size is 0.15 to 0.3 millimeters and can be seen with the naked eye if you look carefully. Matsumoto has named this mark microball lightning, and we have unified it with microball lightning in this proposal. So, so essentially he's saying that this is a microball lightning cluster, and I would suggest that that is the case. Now, it could be the case that in the center you have these exotic vacuum object structures in the center of each of these tiles, as it were, and that around the outside you get whatever produces this line. Takaaki Matsumoto is saying that you get a positron and an electron bound together by the antineutrino that's also released when, the neutrino that is released when a neutron is made into a proton and a positron. So the electron condensate polarizes the protons in a nuclei, and they emit a positron and a neutrino, and you just get neutrons in the core, and that those positrons, electrons that are already there on the outside, matching every proton that's in any nucleus. You have a positron and electron, and that's not positronium, it's an iton when it is bound together by a neutrino, a nuclear neutrino. Okay, so that is the iton. Whatever, it actually is not important, other than the fact that we know microball lightning effects occur in cavitation. We've shown that. I believe we've proved it with the production of the same structures, these crenellated iron and oxygen rich spheres that are produced in actual ball lightning in Hessdalen in Norway, and we produce them in other plasma systems and so forth. And that is the thing that is doing the work. So performance when put into practical use, phase 2. So the target is 1.25 million tons of ALPS treated water to be rendered harmless. The ALPS treated water concentration is 620,000 becquerels per litre. Detoxification concentration is to 1,500 becquerels or less per litre. Target reduction ratio is which is half to the power of 9. Half-life of the proposed technology is 4.25 hours. Detoxification achievement period is around 1.6 days. And like I say, I think this would be longer, and I argue that it would be longer because you've got some statistics involved. You're not relying on a natural decay in a volume. You're relying on the interaction between the vibrating plane, the cavitation spots, those yin-yangs that we've identified, and how fast they can do those. So I think there will be an asymptotic relationship there, but I still think whatever it is, it will be highly beneficial to the overall remediation of the stuff at Fukushima, with the proviso that the active agents may be lasting for up to 2 days and may interfere with scintillation, and we need to verify, in my view, that we are not seeing a spurious result caused by the increasing blocking of the scintillation sites in a scintillator. Number of processing times in 10 years, and essentially what they're saying is the lifetime of these vibration systems is 10 years, and so you can do this processing 2,280 times. So there's a lot of headroom, is what they're saying, in the mean time before failure on the apparatus. Number of 5 types of practical machines is this, and so they're saying you need 110 units. 110 units for detoxification of 1.25 million tons with a footprint of about 1,100 meters squared. And what they're saying is, in the notes, is the cost required for ocean release is estimated to be 400 square meters, so I guess that's the area that's required. 3.4 billion yen, 91 months, excluding tunnels. So they've got to build the tunnels first. They have to go a kilometre out into the sea, okay? And the other tunnels that have to connect to the processing and mixing plant and to the pumping houses and so forth. So just the actual room where the mixing occurs, I guess, is going to take 400 square meters. According to this plan, the installation area is 3 times that. So they are saying that they would need 3 times the amount of space. However, unlike the tank, it can be stored in a multi-story, so they can make a multi-story building. Because there's a real problem at Fukushima. They can't expand the size of the site but they've basically run out of room because it's just filled with all this tritiated water that is in tanks, and there's no more space to build anything. So there's a huge space premium. And so what they're saying here in the comments is that they could make a multi-story building doing the processing, and that this would make it less than 400 meters, depending on how many stories you put up. The processing period can be done in a short amount of time by increasing the number of units. Shorter amount of time. Considering the life of the equipment of about 10 years and about 120 months is considered to be a reasonable period. So they're basically saying, like, okay, 120 months is like, the period for the lifetime of the devices. The price is about 30 million yen per unit if you divide it by 3.4 billion yen of 110 units. But I understand that it is a competitive figure. So what they're saying is that if we were to exclude the cost of all of the tunnels and everything that you would need for the dumping the water into the sea, then they are suggesting that if you just take the processing equipment cost, is estimated to be 3.4 billion yen, and that comes out at 24 million. And if you were to say that's 24 million and you only need 110 of their units, then you're talking about $250,000 roughly dollars per unit. So that is very, very possible for these, I think, 5-ton units or whatever they are looking to do. So I think it is very easy for them to be competitive given those sort of numbers is, I think, the argument that's being made there. Scale of the proposed release, and so this is talking about some stuff here. Its comparison with ocean release is equivalent in terms of amount, duration, and footprint. The basic differences are the environmental impact is dramatically reduced to 2 in 10,000. I guess that means that, you know, they don't actually have radioactive material effectively that's or very little compared to the environmental impact of the actual just dumping it into the sea. So because when you dump this water, in theory, it won't be radioactive. Motivation for drafting the proposal. It was discovered that Nippon Techno and Seikyo Kaihatsu, okay, that's the Japanese company that Miyake is associated with, and I think actually it's not sacred environment development, it's actually holy environment development, so, or whole environment development. I think it's holy environment development, but the translation was not so great there. Had produced data that would not have been possible without the existence of room temperature nuclear transmutation. Okay, so they're saying unless room temperature nuclear transmutation is possible, they couldn't have produced the data that they saw. Okay, I've argued there's possibly one case that needs to be verified where it might be an artifact, but I don't think that's the case overall. But just for honesty and truth and reality, we need to be aware that might be the case. They asked the Nuclear Waste Management Center. I don't think that's correct. I think that should be something else. They call it back room something, but maybe that's correct. To measure the data from their company. And when they did so under the experimental conditions set up by the center, they reported that the radioactivity had definitely decreased, although the cause was unknown. A survey of room temperature transmutation techniques revealed that Takaaki Matsumoto had published the Natto model a quarter of a century ago. Bob Greenyer of the MFMP learned about Nihon Techno, this is Japanese techno, technology, and came to Japan in 2019 to investigate, and succeeded in photographing the exotic vacuum object mark on the wing of the oscillating transmuter, which is evidence of room temperature nuclear fusion. The EVO, personally, I think there's a lot better evidence that was in the study, but anyway, that'll do. The exotic vacuum object mark was also discovered by Takaaki Matsumoto, who named it micro ball lightning. British and Japanese technologies were combined through the medium of Japanese technology. We are convinced that proving this principle will be, with this proposal, is a worthwhile experiment. I fully agree with that, Miyake. So the notes here, just to see if there's anything different with the notes here. The first thing we came across was the sprinkling functioning water from this company, Seikyo Kaihatsu, which I think we're going to call Holy Environmental Development here, on a factory premises would make the radiation disappear. Since the water had the effect of washing away Since water could have the effect of washing away the radioactivity or shielding the radiation with water, we conducted experiments in containers to ensure that the washing away did not occur, and comparison tests between functional water and tap water were conducted to confirm the decontamination effect of functional water. So this is water that they produce themselves, and I believe this functional water will have these relatively short-lived, probably around about 2 days, exotic vacuum object structures in there, and they are able, because they are able to persist, as we saw on Bogdanovich's plasma flow discharge system. These things were able to persist on metal for 2 days. And I think if you got those glowing objects that they saw moving around on a microscope, published in May 2019, if those interacted with a radioactive material, it would make them fall apart. Why? I think it's explained by the 2009 paper of David Freiberger, sponsored by the US Department of Energy. And I think it is because these toroidal, what he calls the diality angle, this EM structure, fractal structure, goes through a critical threshold, and this causes nucleon decay. But if it only needs to be able to destabilize something that wants to decay already. And in the case of tritium, it wants to decay a lot, because it's already unstable. So it wants to. This is where I have an issue with this paper. That it's saying in one case it's fusing to helium 4, but actually it should decay to helium 3. So this is why you need that residual gas mass analysis. But anyway, that aside, it should force the decay of the already unstable structure, and given the fact that it is only 12.3 years half-life, that is a lot more unstable than, say, potassium-40, and it would seem that this technology is very readily able to decay potassium-40, which is, I think, 0.3 times the length of the universe, that supposedly that the universe has existed. So vastly longer half-life, although it is the second most unstable primordial isotope. That's potassium-40. So in this instance, I think that the threshold is reached, or that these clusters, which can be either electrically bound or magnetically bound, can, it would appear, form these spherical clusters, and that they would then take the material inside, end up collapsing the matter in the electronuclear collapse and causing the fusion of material, which is one of the processes. It could even cause the complete collapse of the material. So there we go. So decontamination effect of the functional water. Experiments at the Nuclear Waste Management Center did indeed reduce radioactivity. However, there were cases where the radioactivity did not decrease, and we were unable to definitively determine the effect. Next, we discovered that the functional water from Nippon Techno did indeed reduce the radioactivity. In 2019, an expert in room temperature fusion from the UK came to Japan Techno to carry out technical research and discovered a mark on the vibrating wings. He was very excited to find that the marks on the oscillating wing were similar to those on Matsumoto's microball lightning electric field. Around that time, I learned that 9 Sigma was inviting applications for tritium separation technology, so I organized a team and applied this time. Okay, so that's where we are. So the proposal team members are, and Takaaki Matsumoto has joined this team, former Associate Professor of Atomic Engineering, Hokkaido University. He is the inventor or proposer of cold fusion Natto model, and he lives and works in Sapporo. Hiroyuki Harada is Certified Chemical Engineer, SDG's Society of Engineers. He is the Natto model patent co-inventor along with Takaaki Matsumoto, and he lives and works in Yokohama. Saichi Noguchi, JFE Engineering Plant Construction and Operation, and he lives and works in Fujisawa City. Roy Shinamaza, President of Japan Techno Limited, manufacturer and sale of transmutation equipment and high-speed vibration equipment, and he lives in Otaku, Tokyo. And then the proposer here, Yuji Miyake, SDG is Association of Certified Engineers, Certified Machine Engineers, and he is the proposal summary or proposer of this. And he lives and works in Yokohama also, so they work together. Okay, so there's a bit of history here. We met Mr. Matsumoto by chance through an English acquaintance and discovered by coincidence that he and engineer Harada, who had been fellow engineers for 15 years, I think he's been fellow engineer with Harada for 15 years, had jointly applied for a patent with him 30 years ago. So this, I think Mr. Miyake had been working with Mr. Harada for 15 years, and it turns out when he was investigating this that Mr. Harada had jointly applied for the patent with Matsumoto in this technology 30 years ago. Mr. Seiichi Noguchi had proposed the technology to President Amaza and believed that we would have the opportunity to show his skills in the phase of practical application. So this is the phase 2 practical application. Coincidence brought Mr. Matsumoto and Mr. Harada together, and they had the good fortune to become team members. I believe that coincidence is a good omen. I believe it is too. I believe all of these things are meant to happen. And like I say, a lot of these guys are octogenarians, and we need to move. We need to do whatever's possible to make this happen. Okay, so there are a whole bunch of other links there, and I will show you some of the other materials that were included in the proposal. Okay, so let me pull up those PDFs that were included in the proposal, because I think it's important to show those so you can see what they had to evaluate. So first up is some more detailed images of the vibration plates, and you have seen all these things and know and love them. So yeah, it's a 5-litre vessel, so you can get an understanding. These are PTFE spacers, insulators, and here you can see the steel plates, and this is the titanium or steel plate, and here is the vibrator at the end of a period of time, or this is 0.5 microsieverts at the beginning, and so on, and this at the end 0.11 microsieverts. Here is the data over a period of time, and okay, so this is actually the detector that was used. So this is an SM5D. So so this is from Germany. I don't know whether so this might be a Geiger counter or some sort of scintillator. I think this is the device that was used, so this might help to answer the technology that was used. So I'm not aware of this, but it might just be a normal scintillator. So we need to check on this. It might be that this has a pancake on the back, like this one here. And that because it's a weak beta, they might have taken a water sample and put it over the sample and seen the beta coming up to the mylar window of the pancake on something similar to this. In which case, I'm not sure. The electronics might be affected, but if we need to check. But if this is the type of device, then it is quite possible that those are real and reliable measurements, because this hasn't got photoscintillation sites, and so that would then negate my requirement for the 2-day testing. Still, I'd like to do the 2-day testing just to be sure there was none of the interaction with the PN junctions in this device, which is also mentioned by Shishkin as a way that these can fool electronic devices, and something that also was mentioned by Dr. Takaaki Matsumoto in a paper that he presented in 1995. So I would still like to do the 2-day test, but I suspect that this might be a pancake detector, but I don't know. We can find that out in the next day or two. Here are the slides that they presented about strange radiation and exotic vacuum objects. I didn't translate the top there, but you'll have seen these before. There is a risk that this is a particle and it's traveling around using vibration, but it's not important because we saw all of the forms of strange radiation tracks on the vibrator plates of Dr. Roshin Amaza. And here is some that were shared in things like quartz and boron nitride by Alexander Parkhomov when exposed to electrolysis in the woodpecker experiment. So this effectively is creating these exotic vacuum object structures that are able to travel out and just chew through some of the hardest material known to man with impunity. This is very interesting because this particular structure, which was actually inside some glass, or no, it's this one, I think it was inside glass. This one here has these long tracks, but these side tracks, so it looks like there's something orbiting around, or something that's moving forward. And we replicated something very similar, which you can see here, where you have these offset sections. And this was I observed on the Lion reactor, which we know produces all of the features associated with quantum coherent nuclear reactions as defined by the 1992 Mikhail Solin patent. And this same type of structure was in electromagnetic vortex paper by Takaaki Matsumoto. So this is, in my view, the same kind of feature as Matsumoto had witnessed, and I believe that this one here, which is actually, I think, in boron nitride, the second hardest material after diamond, and I notice here that it looks like the Lion quartz track. So I know Matsumoto would have seen this, Dr. Matsumoto would have seen this and go, well, this just looked like what I've seen. So, okay, so those are those tracks, and I guess that's why they've picked these out to provide, and they can argue to them. The same slide that we saw before, and then this is our famous figure of 8. I was actually going to, and it's actually a cardioid overall. I'm not showing you anything, am I? What an idiot. Let's start again. So we've already seen these before. Sorry. Okay. So we've seen this before. Okay. I'm talking about these in the work of Dr. Alexander Parkhomov, who would readily join and support this process. Okay. So these are in like alumina or boron nitride or quartz. Okay. And there are no identical tracks in his case that he observed. But this is coming from, I believe, the woodpecker reactor, which effectively is a pulsed electrical ball lightning generator or coherent matter structure generator or exotic vacuum object generator, and these are the structures that are flying out of that device. Or this may have been in one of his nickel hydrogen systems. Either way, you can check in the video on the channel, and it would have been in one of the systems, but either way, it's the same thing that's doing the work. Okay. Here again, these kind of periodic tracks, this being for me the most interesting because this is in boron nitride, and that's the second hardest material other than diamond, and that we saw a very similar track here on the outside of the Lion reactor, and that this exact type of track was observed by Matsumoto in the 1990s coming from his experiments. And in actuality, we've seen something very similar to a ball with this helical structure behind it on the eastern plateau of the Vega Valley. So I think we've actually seen the physical manifestation of the collapsed coherent matter structure that would have done something like this. In Matsumoto's work, he actually had a ball at the in the X-ray film or whatever witness material. It might have been a copper plate. He had a kind of ball area or a circular area at the end of a trail that looked very similar to this. So I think this is pretty conclusive. This is also, in my view, critical to understanding this process. So you can imagine this rolling around and producing these weird tracks. But here's one in 1993, which we discussed earlier, and here's a couple of examples on Roshin Amaza's vibrator plate. This is also on Roshin Amaza's palladium-coated vibrator plate, and we showed the data at ICCF 22 in Azizi, where there was transmutation using these systems. I think it was it with this one? Yeah, I think it was with this one. But anyway, you can see this cardioid shape here, but also the figure of 8 structure here. In fact, I was going to do a proposal presentation for how I think that these might occur, using, I think, work from 1907 based on some Maxwell ideas that was published, I think, in a peer-reviewed paper, and also the fact that it's up and down and these two cones that we get in the yin-yang structures. But I will leave that probably until after ICCF 24, but I think it's a very important discussion to have to understand potentially what's really going on and resulting in this focusing and cohering of matter. But anyway, he included that, and that is that for those pieces of supplemental data. This is the patent of Dr. Roy Shinamaza. This is a technical document on the equipment involved and some examples of claimed transmutation. And I think this is actually some additional data from other experiments. And then here is some other patent information, I think, and also this is patents held between the parties involved. Some of them are expired and some of them are close to being expired. This one here, I think if I translate, I can't remember what that was. I did have it earlier. Let me just quickly translate that. That's the one that has the longest life, but what is it? It is supposedly how to produce flammable gas bodies from carbon dioxide and oxyhydrogen gas. So that is the patent that they have there. So this is how to basically produce a fuel that uses oxyhydrogen gas and carbon dioxide. And so we've discussed how Dr. Roy Shinamaza talked about having a device that could burn carbon dioxide and have it as a mixed fuel. Okay, so that is the presentation I have for you today. I'm going to see if you've got any comments. But that was Fixing Fukushima, Second Bite of the Apple. And this is, the point of the MFMP has always been to see if there's something real. And if there's something real, try and educate about it and then help other people bring these things to fruition. Because the plethora of applications of this technology are vast. And this needs to be work that is carried out by large swathes of people all over the world. And it is interesting that we now have a really good collection of people who have history and a story to tell and about how they meshed and came together. And how there was kind of like a story arc. It would make a wonderful movie because you have two people, one of which made a patent with the other person, and then they get connected, and then they're trying to fix this radiation, and then these people invite these people. They're all kind of like connected, but of course, when you do get to the certain high levels of technology, you end up being in circles where people are connected to each other. But anyway, I just think it's rather beautiful, and it would just be a deep honor to be able to work with these people. And I'm sure Slobodan and Alexander Parkhomov and Henk and Alan Goldwater and David Boutelier, I'm sure they'd all be extremely happy to be a part of the story. And so that's where I think we need to try and push it in that direction. And I have to say that Mr. Miyake was one of the very first people to buy one of these books, and he said, "Thank you. This comes at exactly the right time." And so hopefully the people involved can get access to this book and they can have it in their hands. And I know from experience there's a very little amount of information that someone can take on new in any given amount of time, because they've all got things going on in their mind, they've got their own things to deal with, they already have their own beliefs and so forth. But if they have an opportunity to have something in their hand that when they're bored they can kill a few minutes looking through, I think that is not something people want to do in front of a computer. They might want to sit out and have the cherry blossoms, or they might want to sit and just chill out and look through the book. And I think it's inspirational, Takaaki Matsumoto's book, and it has ideas and concepts in there which are persistent things that people have had some sort of lingering questions about how these things occur, and to find something that is natural, ball lightning, which can be manifested in the lab and can explain a good number of these things that have hitherto been unexplained in nature. I think that's going to be a wonderful read, and this is where it's a social exercise. So I hope that the book is very well. I mean, it's basically at cost, all bar a bit of just something on top to make it possible to manage. But I hope people can take the opportunity to go out there, get this, share it, leave it lying around so that other people accidentally get to read it, and that we can push the social side and facilitate people who might be decision makers to push this forward. So that's kind of like I was determined to get this out, and because I wanted to refer to it in my poster at ICCF 24, it was so necessary to have this available for people to go, okay, well, what is he talking about? And then if you've piqued someone's interest at that point and then they don't have access to the supporting material, you've lost them. They're not going to do it again. So it was critical to have this available for people. So try and push this to #1 if you can. It's a cheap purchase, but it's a lot of money for some people. I know, I appreciate that. But it's the pinnacle, or so far, of Dr. Takaaki Matsumoto's work. I would like to think that fixing Fukushima, this would be the pinnacle of his life's achievements. And I know it's something he's very passionate about. I know it's something that Dr. Roy Shinamaza is about. I know that it's something that Sho is passionate about. And now we've got Miyaki Yuji, who's also very passionate about this character down here. And I would love for the opportunity for the MFMP collaborators to work with these people on this slide here. Okay, so I'm going to have a look at your questions. I'm probably going to get rest now, because I'm going to have to be awake every single night this week, and I need to finish my poster. I'm actually obviously not in America, and it's very sad. I would love to have been there, but it is what it is. Essentially, yes, you might be allergic to something, said the allergy clinic, but we have alternatives. The fact that one of those alternatives is considered not appropriate now in the US, it was safe and effective, and now it's not safe and effective in the US, but it's still safe and effective here. Yeah, it is what it is. Okay, so I'm going to have a look through your comments and see if I can pull anything out that to clean up. Yeah, so first name, last name. It's a shame that Stanley Myers died. There's no reason why these people do not... Slobodan, what happened with the first proposal is they came back and they said, well, basically there's no quantitative and qualitative data. We encourage you to submit your proposal at a later time when you could do that. You missed that discussion at the start of the presentation. Essentially, we found the way to get the qualitative and quantitative data. However, we couldn't get access to their material. So then we had a fallback position, which is to use the control tritiated water for the scintillation device. But unfortunately, that is not available to someone who doesn't have the capability to receive radioactive samples, and therefore then we couldn't find anyone that would assist us in meeting those requirements. So it basically hit hard stop, and that's where that happened. But the good thing is the work that was done inspired Yuya Miyake, and they have worked to fix those inadequacies. They have been gracious enough to give credit to the project's work and to the other people that were mentioned in the project, and even to invite us to be a part of that process moving forward. So I think I have immense respect. There's so many people I've seen in this field that have seen the work that project members have done and then run with it and forgotten to mention where they found out what they're doing, and that's okay. You know, that's human nature. But you know, every single time that's conceivably possible, I believe that the project has tried to credit all those people, even when they've just made a comment that's led to something interesting. That it's important that people get credit, so that they feel that when they are spending their time doing research as a person in the crowd, as someone with different life experiences, but just has a bit of intuition, it's important that that person gets credit. I've always felt that from the beginning of the project. You don't give people credit for what they've done, you're killing yourself. You're killing everyone's effort. You're just dampening the whole process. So this is a guy I would like to work with, and I would like to think that other members of the MFMP that I know can contribute in this will want to work if the opportunity arises. Yeah, Stephen, there are a lot of these tracks that look like they've got some artistry codification in artifacts. So yeah, Dave said book ordered, excellent. I think in the UK you can get it fastest. I'm having to wait till August to get mine here from Germany. But I think if in the UK I could get it in a few days. I think there's going to be people that have the book before the middle of next week. What level of maths do you need to be able to help research this? I think you need to be able to work out. I've tried to avoid maths, but if you want to get into the real weeds, the only maths that I've presented in almost the entire process here is that of Nevesky from 1993 and of David Freiberger from 2009. Occasionally, I think there was a Greek guy that I presented some, but you know, and also there's some maths in Dr. Parkamov's book, but he says, well, if you don't want to look at the maths, just it's here if you need it, but you can skip to this next section. So it's generally not necessary. I think the statistics involved with this are relatively simple. Have you got a half-life? Is the radiation being reduced? So I don't think it's a huge maths thing, but there could be contribution to be made for sure in maths. Yes, Ken, a water vortex tube might be valuable for maybe doing a pre-concentration on the heavier water component. So in a Schauberger type way, or if you were to use this technology directly to remediate the waste without having to go through the ALP system, which may be technically possible, although you would end up with a much hotter vibration system that would not be able to be maintained as easily. You could use that to separate, but I don't know actually that the ALP system doesn't have some vortex-based separation initiation phases. I know it's things like zeolites, filters and stuff like that, and maybe some sort of ionic filters going on in there, but they may actually have some sort of vortex type separation. Well, Maria is saying, could radioactivity be destroyed by paired sound, maybe two frequencies in long time exposure? Whatever sound you put into these systems, you always get harmonics, and depending on the resonances of the rest of the system, you get other overlaid sounds. So hit a bell, or I don't know. You get a lot of different sounds out of something if you hit it with energy. It's kind of what I'm saying. Now, what is important, it would seem, is the particular parts of standing waves on rigid surfaces. So when we look at a Mars vibrator plates, they have these spots, and the interesting business appears to be going on in these spots and coming out and from them. And we've effectively replicated this in simpler systems, but that are less robust than the very heavy engineering and simple to maintain structure that is Dr. Roy Shinamaza's technology. But it is sound, and even when you talk about vibrations at phonon levels, they're effectively vibrations like sound, but they're just not in the audio range. Maria Ekman, do you think there's a probability for any Nobel Prize in the future? It's not a concern, really. It's just not important. Yeah, it would be nice if Takaaki Matsumoto got some recognition for his work. Absolutely, Gordon Doherty. So he says, talking about things often irons out understanding and helps improve memory. Last week for me, it was nickel 62 being the most stable element. Yeah, absolutely, Gordon. So through repetition, often when I'm talking in these live streams, I'm challenging myself to be as accurate as I can be. Now, in last week's live stream, I said gallium 152 accidentally. Obviously, I was referring to gadolinium 152, and you know, if someone was proficient in the art or skilled in the art, they would hear the word gal and 152, and they would know that I was talking about gadolinium. But if someone didn't know that 152 was referring to the isotopic number, the number of baryons in there, and they just heard gallium, they might think that I was talking about gallium, but I wasn't. I was talking about gadolinium 152. So you can always make mistakes. So there's no harm in that. Is like the trying to be perfect is the enemy of the good. But also when you're talking through things, you realize things. So like in this presentation, I worried that there could have been this scintillation site. In this review of this presentation, I worried that there could be this issue with the scintillation site errors. However, if they are, as I say, using a pancake detector, that might not be a problem. So yeah, Scotty Sales says, someone has recently been doing work on Myers. Yes, go and check out my blog. There's been some excellent comments on there and links to this other person's site. So please go and have a look at that. Myers' work is important. It's just a shame that things weren't made clear or it didn't deliver on its promise. But it is coherent matter technology. It's the same technology. Oh my God, I can't tell you how hot it is in here. And this is the cool day we've had this week. If my computer melts and just stops, then that's why. Just follow the reflection in his glasses. Yeah, you can go back and edit your own copy and drop over the images when I was talking. Okay, it's nearly midnight here, so I'm just going to do a recap. I'm going to see if there's anything down the bottom. If there's any questions, go to remote view. Please ask them there. What is the easiest way to create scalar waves? I think probably is to do what we did in the Lion, not the Lion, the first video of 2, or the second video of 2 that I shared on the first videos from the Vega experiment. And how to do that will be described in the book. But essentially, you create the Coulombic explosion from the exotic vacuum object, and that produces these electrons that were in a coherent state that then are regain their charge, and they suddenly go outward like this in a spherical or hemispherical explosion, and that I believe creates a scalar EM pulse, EMP. Okay, so I'm just going to quick run over the presentation. So from the beginning, fixing Fukushima, second bite of the apple. Essentially, this was a kind of like a rehash and improvement with a better team. Put together, more Japanese focused, and with the sensibilities of the Japanese culture. I think the proposal is excellent. It does provide some qualitative and quantitative data, and so I think really I hope that they get an opportunity to proceed to phase 2, and I look forward to working with them. So essentially our proposal was then picked up by the proposer here shortly, a few days afterwards, 2 weeks afterwards in fact. I think he followed the progress, as it appears that he's followed the project, because he was trying to find a way to explain the supposed transmutation that was going on in their own hydrogenated water systems, which I would argue are containing these active agents for a period of time, and so they probably would do what is claimed. And I gave an example of a similar kind of occurrence with John Hutchison, and that the work of Bogdanovich in a water plasma system published in May 2019 in a peer-reviewed journal probably would explain what's going on, and this whole 2-day thing comes in. The 17th of March, we tried to find a way to fix the request via 9 sites, and we just hit a brick wall with legal issues. And Yu Miyake has made my point that I made, but in a better way, I believe. So thank you. That really TEPCO has to work with participants in order to be able to produce a workable proposal. So, and if we go back to the start of this presentation, so it was proposed on the 30th of June 2022 by Yuji Miyake, and he was talking about why we have to work with 9 Sigma and TEPCO, and that really, you know, the other solutions which are being asked to be provided are financially impossible. But cold fusion isn't essentially a solution to the request for proposal. It's a solution to the whole problem potentially. And now there is a good understanding, even in Japan, that the technology actually is real and it can deliver other aspects that it promised from the outset. Okay, and there are several advantages where you can use this micro-ball lightning to even generate power and other elements, and also this process can also potentially decontaminate the forest, which prevents this regular 100-year cycle of re-decontamination from farmland, from runoff from forests. And so it solves the problem rather than leaving it as an intractable problem, which is perpetual. And so we have to work with TEPCO. This is a prototype that was used, or rather a test rig that was used to demonstrate the remediation. This is a proposal of what might be going on, although that might not be the case. The important thing is that whether it is this a process, it is likely that charge separation and some form of coherent matter leads to the removal of the tritium. And there is an observable, apparently, remediation process or change in the rate of emissions from the samples taken from the processed water over just 20 hours. And pending further tests, this is definitely good quantitative and qualitative data, along with the suggestions of how many pieces of equipment would need to be purchased and how long they would run for. To meet the problems that we had in our proposal, and that they use the beta ray measurement with liquid scintillator. So there are other ways that we have used, and that Takaaki Matsumoto, who's on the team, have used in the past to verify that this is what's going on, and there are other ways that we've used that they could use moving forward. We replicated what one of the team players has produced, so this is a independent verifiable technology, and it was within this particular experiment that is the same test rig essentially that you see in their tests to remediate the tritiated water that produced this structure, which was observed in a charge separation by AC electrolysis, whereas this is charge separation by nanobubble production and probably adiabatic surface tension based compression and other aspects. So this is the qualitative and quantitative part again of dealing with the providing a solution compared to the other solutions. This is the motivation that they did their own work and it showed promise, but there was another technology that was apparently in the same line, and that the MFMP managed to verify that. And these are the esteemed members of the team, and they're happy for us to join them. And they are. We looked at some of the other data that was associated in a bunch of PDFs with this proposal. So that was. Oh, and by the way, just for reference here, this is this structure, and this is the title of the paper. Bogdanovich et al. Video recordings of long-lived plasmoids near objects exposed to remote and dielectric effects, high current pinch discharges. So if you are getting charge separation in water, and it produces these 2-day lasting plasmoid structures, then could the cavitation be doing the same thing? I suggest it is, and that this is potentially structure for ball lightning, and you can imagine that between these glowing bits you might have this mesh structure that we observe, and that there's a field form around it that leads to the tracks that we were talking about. And I actually think and there's another point in here where I spoke about this from Dr. Takaaki Matsumoto's work, and we replicated this same kind of thing here, and here, and here. And in this case, you can see that if you actually compare his carbon-rich plume coming out of his lead ball, this is extremely similar to this structure coming out of our indium volcano. So essentially, for me, this is pretty much exactly the same thing. When you look at this sample 383 here, it is 51% carbon, which is triple alpha, and 40.49%. So this is nearly between these two. That is like that's quad alpha. So that is between the two. That's 92 point something percent alpha particles, which are the nuclei of helium, coming out of that plume that we see here, which is the majority of it is carbon. So there we go, and we can see it again up in Matsumoto's. But he had other examples, Matsumoto. So this is a carbon film coming out of the pole. This is a carbon eruption. And like I say, this might be one of these disk sections that's kind of popped off and the coherent matter has collapsed and just the guts of the thing is spewing out. It is a hollow structure. Okay. So that is that. And I will say thank you very much for your time. And I will see you hopefully next week, off and on, maybe, if I get a chance to do some reviews. I actually paid, but I haven't got any login details at the moment. I can't even submit my poster, so we don't know. I don't know how to use the Hopin system, but yeah, I've got all of tomorrow to work that out, so we'll see what happens. So anyway, I'll say goodnight. Thank you very, very much for your time. Dobranoc, buenas noches, buenas sera, good night.